Okay, so welcome back everyone. Let us now see the another question over here. Now what they had asked is they had given a BMD like this. They had given a BMD, which is bending moment diagram, which was something like this. They said first draw a concave down and then draw a concave up. Okay, and this is the beam proposed. Let us say A, B, and C. What they asked was to find or to draw first SFD, second loading diagram. Okay, so see now how we shall proceed. This question might you may feel tricky if you don't solve this properly. So let's say this is positive bending moment, this is negative bending moment here. So we will just copy forward this rotation over here. So see, now the point A is here, point C is here. Okay. Now अभी समझो कि अगर देखो यहाँ पे अगर बेंडिंग मोमेंट इज जीरो ओवर हियर, there must be some support reaction over here. So let us say like this. Okay. I am taking it in positive direction because the bending moment here is positive. Okay. So now it's parabolic over here, so it should be linear over here. And since it is maximum at this point, let's say this point as D and let's say this point as E. It's maximum, so bending shear force diagram must go to zero. As we know, dm by dx equals to V. So for maximum condition, this should be zero. So this will come here like this. Okay. So this is our point D. Now from here onwards, since at point B, bending moment is zero, so shear force must be maximum. Like this. Okay. This was point B. Now, here, now it should rise again like this because see, at E, again the bending moment is say at extremum condition. So shear force must be again zero. So here, if we go and draw, it will be like this. It is a linear line. No? And then again it will increase, rise up to the same level of this. I hope you got this. This is the shear force diagram. And if they want you to do some calculation, you may show it up to them later. Now see how we will construct the loading diagram here. Loading diagram. Point A, C, B. Now see, since it's linearly decreasing here, okay, from this point to this onwards. So it should be a UDL over here. Okay, and since from this point again to this one here, this point here, it is linearly increasing. So they should be like this. Point B here, C. And this should be simply supported D. I hope you got this. And if you do the calculation, it will satisfy eventually. See, if we say this is W, this is W, L by 2 and L by 2. You go and see here, see, RA will be WL by 4 and RC will be minus WL by 4 if we apply the conditions properly. And if we apply summation moment B, Here, see, uh, according to this BMD, it should be 0. Now we can check over here. See, WL by 4 into L by 2 minus, for section AB I'm writing this about you. I hope you will be knowing this. For any either end you should apply. Okay, so and minus W L by 2 into L by 4, which will give 0. Hence it is satisfied. Okay, so this is how this question has to be solved. This part was quite you may find it some tricky part, but if you apply this simple logic, positive, negative, and this one, you will get it easily. And the loading also appropriately you may draw accordingly. Just remember all these things. See, for reverse calculation also, you just have to concentrate on the curve nature. Since it is given parabolic here, parabolic was given. So the SFD will be linear. Since BMD is parabolic, SFD will be one uh, order less than this, so linear. And loading will be straight line, constant. So UDL. Okay. So I hope you got this question. This was a good question. Thank you.